Welcome to MEI Numerical Methods Errors. In this video we'll be looking at some special cases. First of all, we'll see how changing the order of a sequence of operations can have an effect on rounding. So here we've got a calculation which gives an exact value of 5,382, and imagine that we've got a computer where everything's rounded to two significant figures, and we'll consider first of all what happens if the computer does the calculation as indicated by the brackets, so that we're adding 83 and 55 to start with. So that gives 138, and then because everything's got to be rounded to two significant figures, that gives us 140, and then that 140 has to be multiplied by the 39, and then we round that answer to two significant figures again to give 5,500. And then as an alternative method we could expand the brackets first and then multiply 83 by 39. So that gives us 3237, but we have to round to two significant figures again, and then we do the same thing for 55 times 39 to get 2145, and that rounds to 2100. Adding those two together gives us 5,300. So we've got the actual true answer was 5382, and both methods have got an incorrect answer to two significant figures. So it should have been, if we do insist on rounding the final answer to two significant figures, it should be 5,400. So all this illustrates is that the way in which you do the calculation can affect the answer if there's any rounding involved. But the solution is simply to retain more figures, either more significant figures or more decimal places as appropriate. Now in a moment we're going to see what happens if we subtract one number from another where the two numbers are quite close, but initially we're just going to see what sort of result we would expect if the two numbers weren't close together. So we've done this sort of exercise before, so if we although we were using decimal places last time, but if we want to know what the number of significant figures that we can safely quote this the difference between these two numbers to, then we just need to first of all consider the smallest possible value, and so that's going to be the smallest value for the first number, and then we need to take off the largest possible value for the second, and then for the largest value we need the largest value for the first number and take off the smallest possible value for the second. And we can see that it's safe to quote the answer as 263790 to five significant figures, as both of those two values round to that number to five significant figures. So now we're going to look at an example where the two numbers are fairly similar. So we do exactly the same thing and find that the smallest possible value is 0.1880, whilst the largest possible value is 0.1900. And so those two values agree to 0.19 to two decimal places, or two significant figures is what we're considering here. So, and as opposed to the six significant figures that we had previously, so we've got a considerable reduction in the number of significant figures. And now we're going to look at what are called ill-conditioned problems, and this is where we've got an input value which, if we make a small change to it, will result in a large change in the output value. And as an example of this, if we had a quadratic equation and the discriminant happened to be close to 0, then a small change in the parameters, a, b or c, could mean we suddenly flip from having 2 solutions to no solutions, for example. And another example would be where we had 2 lines that were almost parallel, so they've got a similar gradient, so we've got a gradient of 2 and a gradient of 2.01, and if we change the gradient of the second line to 2.02, for example, then we can see that the x-coordinate of the original point of intersection of the 2 lines, so that's the line y equals 2x plus 1 and y equals 2.01 x plus 9, so we get an x-coordinate of minus 800 in that case, and that changes dramatically to x equals minus 400 if we're comparing that line with the line y equals 2.02 x plus 9. So that concludes the videos on errors.